All right, get ready for this one. It's more complicated. So, if we have a Taylor series and we want to think about what its remainder will be, we'll first look at a Taylor series. And a Taylor series is written like this: f of a plus f prime of a times x minus a, f double prime of a, blah, 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 all the way until you have its, quote, final term, f to the n, or f, n derivative of f times x minus a to the n over n factorial. So here's your basic Taylor series. Basic, that's funny. If I go up to here and I stop, so whatever my n is, say n is 6 or n is 3 or n is 8 or whatever degree polynomial I'm looking for, I'm still going to have more that comes after it, called the remainder. Because at some point, if I'm quantifying it, I'm cutting it off somewhere, so there's going to be more after that since I can't go to infinity. So my Taylor series really is a bunch of terms, all written according to the pattern that we figured out, plus a bunch more at the end that's too much for us to calculate. Well, that remainder is considered to be kind of one more than the last term that I end with. So if I'm ending with f to the n, or f of n, whatever, n being the power, my remainder is going to be one more than that last term. So my remainder is going to be quantified as this exact thing, this last term of my Taylor series, except one more, adding 1 to the n. So my remainder is going to be written like this. Taking the n plus 1th derivative of f at some point c, times x minus a to the n plus 1 over n plus 1 factorial. So instead of n being my last one, now I'm going on and having a little bit more, and that's called my remainder. This way to write a remainder is called the Lagrange form of the remainder. It's a good name for a boy right there. And anyway, this remainder, the a value is the place where the function or where the series is centered, just like always. The c value is some c value between x and a. The tricky part of using this is going to be finding that f of c value to the whatever derivative. Because c is going to be some value between x and a. A is where it's centered, so in this case 0, and x is going to be our given x value or values to look at. So what I mean is, you're going to be looking at a problem like this. Let's take f of x is the natural log of 1 plus x, centered at 0. If that's the case, if it's centered at x equals 0, then that means my a is where it's centered. And I'm going to ask, find the error when x is between negative 0.1, and 0.1. Those values are my x values of error that I'm given to look to find. Okay, I don't know if that's clear. So the remainder theorem is going to be used like this, and c is some value between x and a being the place where it's centered, which in this case is 0, and x value is the given x value I'm looking at, so negative 0.1 to 0.1. So c is some number in between. And we'll talk about how to find that in a second. Crap, it's my phone again. Hold on.